Okay folks, these are called Chinese sticks or Chinese wands. In the classroom I simply refer to them as wands. This is a fantastic way to engage your students when you introduce the concept of scientific method, or what we now refer to as scientific inquiry. This is a much more genuine way to introduce the concept rather than the traditional method of listing the steps as a rigid format and having a class discussion on it. In this authentic presentation, your students will actually experience what scientific inquiry is all about. In fact, it will demonstrate to them that they'll have to sometimes go back and revise their hypotheses based on observations they've made. In fact, it will demonstrate to them that hypotheses are actually based on observations. I begin by asking students to take out a sheet of paper and simply illustrate these two wands and draw it on their paper. Simple illustration is fine. Then I ask them to make simple observations based on what they're about to see. I begin by pulling on one of these strings which is attached to one of the wands. Now if I pull on the string opposite and the opposite wand, you'll see the first string rises. I'll do that again. When I pull on one string, the opposite one rises. And I'll ask students to illustrate for me or draw on their paper how they think these strings might be connected. I'll give them a few seconds to do that. And then I'll go around and look at their diagrams and have a class discussion. Ask students to share out their ideas. You'll find that the most plausible or common idea is that the string goes up, across the sticks, and down the other wand. And in fact, that makes the most sense. Ask them how we could test that hypothesis out. And you'll find that they'll say we should separate the wands. Do that and show them that in fact they are not connected there at all, but they still operate. Now they'll have to go back and revise their original hypothesis based on these new observations, because the strings still operate even though they are not connected. Ask them to draw now a new illustration showing how they think the strings are now connected. Give them a few seconds to do that, and then ask again, what are your new hypotheses? Share out. You'll find that the most common, and again the most plausible, is that the string goes up one wand, down the wand to the back, where it rides up the other wand to the front. And it makes the most sense. Very plausible. Ask them how we might test out that hypothesis. And they'll say, separate the wands. Makes sense, let's do it. It should be connected basically right back there, but you can see that it's not. And yet, even though the strings are not connected in the back of the wands, they will still operate each other. You guessed it, now we're going back to the drawing board. They're going to have to go back and revise their hypotheses again based on these new observations. Ask them to make new illustrations on their paper based on these new observations. Give them a few seconds to do that, and then share out again. You'll find at this point that the most plausible and common explanation is going to be that there are magnets involved. And again, this makes sense. If the wands are right next to each other, magnets could conceivably operate these strings. How could we test that hypothesis? What could we do? Well, you could hold one and I could hold the other, and in fact you can do that. In the classroom you can have one student hold one wand while you hold the other. I'm going to just take one of these wands and simply put it under my arm right now, and I'm going to pull on this one. Since they're separated, we're going to test to see if magnets are involved. So if I pull on one string, yep, the other one still operates. And so this disproves the theory or the hypothesis of magnets, because they still operate when they're separated from each other. Now we're going to make a new hypothesis. Based on these new observations, how do you think they operate now? Students will now struggle a little bit. They'll be challenged trying to figure out, but you'll be surprised at some of the creative ideas that you actually get. Share out. This will be a fruitful discussion. You'll find that some students' ideas will actually generate other ideas in other students. And after a while, you can actually show students that, well, this happens once in a while. Actually, the Chinese wands or the wands actually get stuck once in a while, and you can ask for your students to help out with this. You're going to use their invisible hair. Just reach out and grab a piece of their invisible hair and tie one end on this bead and stretch it across to the other wand right there, so that their invisible hair is now stretched between the wands. Ask them to grab their invisible hair and pull up slowly, just like this, and help you fix your wands. These are called Chinese wands, Chinese sticks. Again, this is just a great way to introduce the concept of scientific inquiry. I usually end right here. I do not show kids, I do not show students the secret to this trick, and in fact that is also genuine or authentic science. And I explain to them that sometimes when you do a scientific investigation, sometimes you don't have that answer you're looking for. Sometimes there's not a neat conclusion in the end. Sometimes, in fact, the observations that you make and the results that you gather will actually lead you to more questions. A genuine way of introducing scientific inquiry, the Chinese wands.